Hello, in this lecture I will answer two questions. In the first question, we find out the radius of this circle, and in the second question, we will find out the area of this green shape using two different methods. So we start with the first question. In the drawing, we have quadrilateral ABCD that is inscribed by this circle. AB equals to AD equals to 4, BC equals to 6, DC equals to 8. Again, our task is to find out the radius of this circle. So first of all, we define this angle BCD is theta. This is the opposite angle of theta. The sum of those two angles must be equal to 180 degrees according to rule 70. So please click on rule 70. According to rule 70, in a cyclic quadrilateral, the sum of the opposite angles is equal to 180 degrees. Quadrilateral ABCD is a cyclic quadrilateral because it is inscribed by this circle. Therefore, the sum of those two opposite angles must be equal to 180 degrees. That is to say, alpha plus beta equals to 180 degrees. Likewise, the sum of those two opposite angles must be also equal to 180 degrees. That is to say, gamma plus beta, gamma plus beta must be also equal to 180 degrees. So we can implement rule 70 in our drawing. Therefore, quadrilateral ABCD is a cyclic quadrilateral, and therefore the sum of those two opposite angles must be equal to 180 degrees according to rule 70. So angle theta plus this missing angle, total the sum of those two opposite angles must be equal to 180 degrees. Therefore, this missing angle must be equal to 180 degrees in its size. 180 degrees minus theta, of course. 180 degrees minus theta in its size. Well, because 180 degrees minus theta, 180 degrees minus theta plus theta equals to 180 degrees, the sum of those two opposite angles in the cyclic quadrilateral ABCD. Therefore, this missing angle must be equal to 180 degrees minus theta according to rule 70. So in the next step, we will join points B and D together by straight line. By joining points B and D, we divided quadrilateral ABCD into two parts. The first part is the upper green triangle ABD. And the second part is the white triangle BDC. So we will implement in the next step, we will implement the law of cosines on both triangles. So please click on the law of cosines. The law of cosines is true in any triangle. This is triangle ABC that could be any triangle. This is angle BAC. This is equal to theta degrees in side. Side AB equals to everything in itself. Side AC equals to everything in itself. Side BC equals to everything in itself. So this triangle BC that could be any triangle according to the law of cosines. The following equation is true. C squared equals to A squared plus B squared minus 2 times A times B times cosine theta. Again, C squared equals to A squared plus B squared minus 2 times A times B times cosine theta. So we can actually implement the law of cosines in this green triangle, triangle ABD. So in this green triangle, triangle ABD, according to the law of cosines, The following equation is true. BD squared equals to AB squared plus AD squared minus 2 times AB times AD times cosine 180 degrees minus theta. Again, in this case, time ABD, according to the law of cosines, the following equation is true. DB squared equals to AB squared plus AD squared minus 2 times AB times AD times cosine 180 degrees minus theta. We have the trigonometric identity that says that cosine 180 degrees minus theta equals to minus cosine theta. Therefore, we can substitute cosine 180 degrees minus theta in this equation 1 by minus cosine theta. So, here according to equation 1, if you found out that dB squared equals to AB squared. AB is 4, therefore AB squared is 4 squared, that is 16. Plus AD squared. AD is 4, therefore AD squared is also 4 squared, that is 16. Minus 2 times AB is 4, times AD is also 4, times cosine 180 degrees minus theta. And cosine 180 degrees minus theta equals to minus cosine theta. So here we have minus times minus is plus. So this expression is a positive expression. So in total, we should know that according to equation 1, dB squared equals to 16 plus 16 is 32. This is a positive expression, so it is plus 2 times 4 is 8, 8 times 4 is 32. So in total, this expression equals to 32 times cosine theta. So in total, according to equation 1, you actually found out that dB squared equals to 32 plus 32 times cosine theta. In the next step, we will implement the law of cosines on this triangle BDC. On this rectangle TBC, according to the law of cosines, the following equation is true. dB squared equals to BC squared plus DC squared minus 2 times BC times DC times cosine theta. And again, in this what I will be this according to the law of cosines, the following equation is true. BD square equals to BC square plus DC square minus 2 times BC times DC times cosine theta. BD is the missing side, so we leave it as it is, so it is BD square equals to BC square. BC is 6, therefore BC square is 6 squared, that is 36. Plus DC square. DC is 8, therefore DC square is 8 squared, that is 64. Minus 2 times BC is 6, times DC is 8, times cosine theta. So according to equation 2, if you found out that BD square equals to 36 plus 64, minus 2 times 6 times 8 times cosine theta. So BD square equals to 36 plus 64 is 100. Minus 2 times 6 is minus 12. Minus 12 times 8 is minus 96. So this expansion in total equals to minus 96 cosine theta. So in total, according to equation 2, if you found out that BD square equals to 100 minus 96 times cosine theta. This is according to equation 2. But according to equation 1, we already found out that BD square equals to 32 plus 32 times cosine theta. So we have two equations for BD square, equation 1 and equation 2. Therefore, we get equation 3. That states that BD square according to equation 1 must be equal to BD square according to equation 2. Very simple equation. BD square according to equation 1 equals to 32 plus 32 times cosine theta, and it must be equal to BD square according to equation 2. BD square according to equation 2 equals to 100 minus 96 times cosine theta. So total according to equation 3, if we found out that 32 plus 32 times cosine theta equals to 100 minus 96 times cosine theta. So here we subtract 32 from this equation 3. So in this side of equation 3, 32 will get cancelled. We left only with 32 times cosine theta. And on the other side of this equation 3, we have 100 minus 32 is 68. Minus 96 times cosine theta. So in total, according to equation 3, we found out that 32 times cosine theta equals to 68 minus 96 times cosine theta. So here we add to this equation 3, 96 cosine theta, 96 times cosine theta. So in this side of equation 3 we have 96 cosine theta minus 96 cosine theta is 0. So here 96 cosine theta will get cancelled. So in this side of equation 3 we have left only with 68. While on the other side of equation 3 we have 32 cosine theta plus 96 of cosine theta equals to 128 cosine theta. So in total, if you hold on 128 cosine theta equals to 68. Here we divide this equation 3 by 128. And finally get that according to equation 3, cosine theta equals to 68 over 128. Here we divide both the numerator and the numerator of this number by 2. 68 over 2 is 34, and 128 over 2 is 64. So here we divide both the numerator and the numerator of this expression by 2, and we will get that 34 over 2 is 17, and 64 over 2 is 32. Those two sides of the equation are equal to each other. That is to say, according to equation 3, we found out that cosine theta equals to 17 over 32. So you know, cosine theta equals to 17 over 32. Actually, we have the trigonometric identity. It said that sinus square theta plus cosine square theta equals to 1. Here we subtract from this trigonometric identity cosine square theta, and you get that sinus square theta equals to 1 minus cosine square theta. So here we'll take a root out of this equation and get that sinus theta equals to the square root of 1 minus cosine square theta. We already found out that cosine theta equals to 17 over 32. So here we will square this equation and get that cosine square theta equals to 17 over 32 squared. 17 over 32 squared equals to 0.2822. And again, cosine square theta equals to 0.2822. And we know that sinus theta equals to the square root of 1 minus cosine square theta. So actually, we can substitute cosine square theta in the trigonometric identity by 0.2822. We do it now, we get that sinus theta equals to the square root of 1 and minus cosine square theta is 0.2822. So in total, sinus theta equals to the square root of 1 minus 0.2822. 1 minus 0.822 equals to 0.7177. So in total, sinus theta equals to the square root of 0.7177. So sinus theta equals the square root of 0.7177 is equal to 0.847. So in total, we found out that sinus theta equals to 0.847. What is the length of chord BD? Actually, according to equation 1, we have already found out that BD squared equals to 32 plus 32 times cosine theta. So B, we already found out that cosine theta equals to 17 over 32. So according to equation 1, BD squared equals to 32 plus 32 times cosine theta. And cosine theta is 17 over 32, therefore we'll substitute cosine theta in this equation 1 by 17 over 32. So now we found out that BD squared equals to 32 plus 17 over 32. We have 32 in the denominator, 32 in the denominator, so 32 will get cancelled. So here we left only with 17. So in total, we found out that according to equation 1, BD squared equals to 32 plus 17. 32 plus 17 is 49. So BD squared equals to 49. Here we'll take out all of this equation and find out that BD equals to the square root of 49, that is 7. BD equals to 7 units inside. And sinus theta is equal to 0.847 according to what we already found out. So in the next step, we will implement the law of sines in this triangle BDC. Repeat again. We will implement the law of sines in this triangle BDC. So repeat quickly on the law of sines. The law of sines is true in any triangle. This is triangle ABC, that could be any triangle. Triangle ABC is described by this circle. AB equals to C units and stuff, AC equals to B units and stuff, BC equals to A units and stuff. This is again BAC is equals to capital A degrees in size. Likewise, this is again CB is equals to capital C degrees in size. And finally, this is again ABC. This is again ABC is equals to capital B degrees in size. So in this triangle ABC, triangle ABC is described by this circle, and the radius of this circle is R. So, according to the law of sines, in its full version, in our drawing, the following equation is to A over sinus A equals to B over sinus B equals to C over sinus C equals to 2R. And R is the radius of this circle that blocks triangle ABC. So again, according to the law of sines in its full version, Now drawing the following equation is to A over sinus A equals to B over sinus B equals to C over sinus C equals to 2R. And now the radius of this circle that blocks triangle ABC. We can actually implement the law of sines in the y triangle BDC in its full version. Why? Because of the fact that the y triangle BDC is described by this circle. That is to say, because of the fact that all the three vertices B, C, and D of the y triangle BDC lie in the circle itself, it means that triangle BDC is described by this circle. For that reason, you can implement the law of sines in triangle BDC in its full version. That is to say, according to the law of sines, BD over sinus theta equals to 2R. Again, BD over sinus theta equals to 2R. And now is the radius of this circle that blocks triangle ABC. So, according to the law of sines, in its version, we implement the law of sines in its version on the y triangle BDC. BD over sinus theta equals to 2R. And R is the radius of this circle that the blocks triangle ABC. R is also the radius that we are looking for in this question. BD equals to 7 units in its length over sinus theta. Sinus theta equals to 0.847 equals to 2R. 7 over 0.87 equals to 8.2644, and it is equals to 2R. In total, if we found out that 8.2644 equals to 2R. So again, found out that 8.2644 equals to 2R. Here we will divide this equation by 2 and find that R, that is the radius of the circle that we are looking for, is equal to 8.2644 over 2 is 4.132. 4.132 units in itself. So in total, if you found out that the area and the radius of this circle, that is the radius that we are looking for in this question, is equal to 4.132 units in its length. So I finished the first question. In the next step, I will present you the second question of this lecture, and also on the second question by using two different methods. In the second question, our task is to find out the area of this vein shape. So in the drawing, we have the big right triangle ABC. This is angle ACB. This equals to 2 theta degrees inside. This is angle ABC. That is the right angle. In addition, we know that AP equals to 5, PB equals to 4, and again, our task is to find out the area of this vein shape. So first of all, we will complete the missing angles in our drawing. we have the right triangle ABC. The right triangle ABC, this is the right angle. This angle equals to 2 theta, and therefore this first angle must be equal to 90 degrees minus 2 theta. Why? Because 90 degrees minus 2 theta plus 2 theta equals to 90 degrees, and 90 degrees plus 90 degrees is equals to 180 degrees. That is the sum of the angles in any triangle. Likewise, in this white triangle PBC, white low triangle PBC, this angle equals to 90 degrees, this angle equals to theta, and therefore this missing angle must be equal to 90 degrees minus theta. According to the sum rule, that said that the sum of the angles in any triangle is equal to 180 degrees. So in the next step, we will do a construction. That is to say, from point P, we will do perpendicular on AC. Again, from point P, we will do perpendicular on AC. So actually, this angle equals to 90 degrees inside, and this angle also equals to 90 degrees inside, according to our construction. We will define the touching point of the perpendicular from point P and AC. This point is point Q. By doing this construction, we get the given right triangle PQC. In the given right triangle PQC, this angle equals to 90 degrees, this angle equals to theta, and therefore this first angle must be equal to 90 degrees minus theta. According to the sum rule, that said that the sum of the angles in any triangle is equal to 180 degrees. So in the next step, we prove that what is the size of this missing angle APQ? Actually, we use here rule 3 that says that the sum of the angles from one side of a straight line is equal to 180 degrees. So the sum of the angles from the left side of the straight line AB at point P must be equal to 180 degrees according to rule 3. So which angles we have at the left side of the straight line AB at point P? We have this missing angle, so we define this missing angle as Y. Plus this angle equals to 90 degrees minus theta, plus this angle, plus this angle is equal to 90 degrees minus theta, plus this angle is also equal to 90 degrees minus theta, and total they must be equal to 180 degrees according to all three. So I can now Y plus 90 degrees minus theta plus 90 degrees minus theta, total the sum of those three angles must be equal to 180 degrees according to rule 3. Repeat again. We define the missing angle APQ as Y, and according to rule 3, the sum of the angles of the left side of the straight line AB at point P must be equal to 180 degrees. That is to say, the missing angle Y plus 90 degrees minus theta plus 90 degrees minus theta, and total must be equal to 180 degrees. So in this of the equation we have Y 90 degrees plus 90 degrees is 180 degrees, so it is plus 180 degrees. Minus theta is minus 2 theta. Theta must be equal to 180 degrees according to rule 3. So here we'll subtract 180 degrees from this equation. So here 180 degrees will get cancelled, so in this side of the equation we have only with Y minus 2 theta, while on the other side of the equation we left strict flapping. That is to say 0. So in total we found out that Y minus 2 theta equals to 0. Here we add 2 theta to this equation, angle that in total y equals to 2 theta. So the missing angle equals to 2 theta degrees inside. Again, APQ equals to y and y equals to 2 theta. If you found out that this is the missing angle APQ that is equals to 2 theta degrees inside. So the norm in the next step, we prove that the grain upper triangle PQC can go into this right lower triangle PBC according to angle side angle rule. And again, we prove that those two right triangles can go into each other according to angle side angle rule. So we have this is the grain upper triangle PQC. We have to prove that this grain PQC can go into this right triangle PBC. So, why those two right triangles can go into each other? First of all, those two angles are both equal to 90 degrees on theta and therefore they are equal to each other. So actually, this is again QPC in the green triangle, and it is equal to this angle, this angle CPB in the white triangle. And again, in total, if you hold on that angle QPC in the green triangle QPC equals to angle CPB in the white triangle CPB, they are both equal to 90 degrees on theta and therefore they are equal to each other. In addition, side PC is a common side that belongs to both triangles, so we can write down that PC equals to itself is a common side that belongs to both triangles. And finally, those two angles are both equal to theta and therefore they are equal to each other. This is angle QCP, the green triangle QCP, and this equals to this angle, the angle PCB, the white triangle PCB. But again, if you found out that angle QCP in the green triangle PQC equals to angle PCB in the white triangle PBC, they are both equal to theta and therefore they are equal to each other. So in total, if you found out that those two right triangles can go into each other according to angle side angle rule. So the green triangle PQC can wait, this is the side of conjoint, to the white triangle PBC. According to angle side angle rule. What is angle side angle rule? In our case, it means that if we prove that those two angles and the side that is included between those two angles, that is side PC in the green triangle PQC, are corresponding equal to those two angles, and the side that is included between those triangles, that is also side PC, this right angle PBC. Therefore, those two right angles can join to each other according to angle side angle rule. We have those two angles, and the side that is included between those two angles in this red triangle corresponding equal to those two angles, and the side that is included between those two angles in the y triangle. And therefore, those two right angles can join to each other according to angle side angle rule. As for the fact that those two right angles can join to each other, we realize that the corresponding angles must be equal to each other and their lengths. That is to say, PQ equals to PB. Repeat again. PQ equals to PB according to the rule that says that corresponding sides that can join triangles are equal to each other. Those two triangles can join to each other, therefore their corresponding sides must be equal to each other in their lengths. That is to say, PQ equals to PB. But according to what is given in the equation, PB equals to 4. So we can write that PB equals to 4. And for this equation, PQ equals to PB equals to 4, we derive that PB must be also equal to 4 units in itself. PB equals to 4. Again, from the fact that PQ equals to PB equals to 4, we derive that PQ equals to 4, of course. PQ equals to 4. Yeah, this is like PQ. This equals to 4 units in itself. It is very easy to see from the drawing that the big right angle ABC is similar to this small right angle APQ. Again, the big right angle ABC is similar to this small right angle APQ. So why those two triangles are similar to each other? First of all, this is angle A, this is the common angle that belongs to both triangles, so we can find out that angle A equals to itself is the common angle that belongs to both triangles. In addition, those two angles are both equal to 90 degrees and therefore they are equal to each other. And finally, those two angles are both equal to theta and therefore they are equal to each other. So in total, we found out that all the triangles of this right big triangle ABC are corresponding equal to all the triangles of this small triangle AQP. Therefore, those two right triangles can go to each other, are similar to each other according to angle similarity rule. So write it down if you found out that the big right triangle ABC is similar, this is the sign of similar, to the green right triangle APQ according to angle similarity rule. And for the fact that those two right triangles are similar to each other, we will derive that the following relationship exists between their sides. We will derive that side AP of the green APQ over side AC of the big ABC equals to side PQ of the green APQ over side BC of the big ABC. And again, from the fact that the big ABC is similar to this green APQ, we derive that the following relationship exists between their sides. We will derive the side AP of the green triangle or side AC of the big triangle equals to side PQ of the green small triangle or side BC of the big triangle ABC. AP equals to 5 over AC. We define AC as A and we define side BC as B. So AP 5, AP is 5, so AP over AC, AC is A according to our definition, and it's equals to PQ. PQ is 4 over BC. BC is B according to our definition. So in total, we found out that 5 over A equals to 4 over A. Uh, 5 over A equals to 4 over B. Here we cross multiply this equation, and we get that 5B equals to 4A. What is the meaning of this equation 5B equals to 4A? It means that if A equals to 5x, what is the value of B? Just substitute A by 5x and we find out the value of B. And get that 5B equals to 4A. A is 5x, so we substitute A by x, 5x. So we found out that 5B equals to 4 times 5x. Here we have 5 on both sides of this equation, so 5 gets cancelled. If I cancel 5, in this side of the equation we have to leave B, but on the other side of the equation we have 4x. So in total we found out that if A equals to if A equals to 5x, then B must be equal to 4x. So here you can find out that if A equals to 5x, then B must be equal to 4x. So in the next step, we'll implement the Pythagoras theorem on the big triangle ABC. And again, we'll implement the Pythagoras theorem on this big triangle ABC. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. So here by PT is the version for Pythagoras theorem. In this big triangle ABC, according to the Pythagoras theorem, AC square equals to AB square plus BC square. And again, according to the Pythagoras theorem, in this big right triangle ABC, the following equation is true. AC squared, that is the square of the hypotenuse, equals to AB square plus BC square. AC equals to A and A equals to 5x. So in total AC equals to 5x. Therefore AC squared is 5x squared. 5x squared is 25x squared. So in total we found out that AC squared equals to 25x squared. And it is equal to AB squared. AB in total is 5 plus 4, that is 9, therefore AB squared is 9 squared, that is 81. So AB squared is 81 plus BC squared. BC is A, BC equals to B, and B equals to 4x. So in total BC equals to 4x. This is So if BC equals to 4x, it means that BC squared equals to 4x squared. 4x squared is 16x squared. So total if you want that BC squared equals to 16x squared. So if you want that 25x squared equals to 81 plus 16x squared. Here we subtract 16x squared from this equation. If I get the 25x squared minus 16x squared is 9x squared equals to 81, and here we have 16x squared or 16x squared is 0. So in total, if you want that 9x squared equals to 81, here we divide this equation by 9. If I get that x squared equals to the square root of 81. Okay, here we divided this equation by 9. So 9x squared over 9 is x squared. 9x squared over 9 is x squared. And 81 over 9 is 9. So in total, if you found that x squared equals to 9, here we take out all this equation. If I get that x equals to the square root of 9, it is this way. So x equals to 4 units in its 9. AC equals to A and A equals to 5x. 5x is times 5 times 3, that is 15. So in total, is equals to 15. Likewise, BC equals to B and B equals to 4x. So total BC equals to 4x. 4x is 4 times 3, that is 12. So BC equals to 12 units instead. Moving on. Our task is to find out the area of this green shape. So what is the area of the green shape? From the drawing, it is very easy to see that the green shape it is actually the green triangle APC. So our task is to find out the area of this green triangle APC. What is the area of the green triangle APC? Now here we know that the area of any triangle equals to the base of the triangle times the height to the base over 2. Therefore, the area of this green triangle APC must be equal to the base of the triangle. We choose the base as AC. The base is AC according to our choice. And the height to the base must rate with the base. A PQ rates with the base, so PQ is the height to the base. Divided by 2. AC equals to 15. This is 15, this is 5 times 3, this is 15. Times PQ equals to 4. Divided by 2. So total, if you want to know the area of the green shape, equals to 15 times 4 is 60, and 60 over 2 is 30. So total, if you want to know the area of this green shape, equals to 30 square units inside. So the next step I present to you how to find out the area of this method according to the second method. Here we focus on this right lower triangle PBC, this right lower triangle PBC, tangent theta equals to PB over BC. But again, this right triangle PBC, tangent theta equals to PB over BC. Tangent theta equals to PB over BC, right triangle PBC. We define the length of BC as B. In total, we found out that tangent theta equals to PB over BC. PB is 4 over BC. BC is B according to our definition. So in total, we found out that according to equation 1, tangent theta equals to 4 over B. So that's known. In the next step, we focus on the big right triangle ABC. So the big right triangle ABC. It's very easy to say that tangents to theta equals to AB over BC. Again, tangents to theta equals to AB over BC. Tangents to theta equals to AB over BC. AB equals to 5 plus 4, that is 9. Over BC. BC equals to B. So in total, according to equation 2, we found out that tangents to theta equals to 9 over B. So again, in total, we found out that according to equation 2, tangents to theta equals to 9 over B. This is according to equation 2, while according to equation 1, we already found out that tangent theta equals to 4 over b. We have the trigonometric identity. That says that tangent to theta equals to 2 times tangent theta over 1 minus tangent square theta. And again, we have the trigonometric identity that says that tangent to theta equals to 2 times tangent theta over 1 minus tangent square theta. So, we already found out that tangent to theta equals to 9 over b. So we substitute tangent to theta in this trigonometric identity by 9 over b. And it is equals to 2 times tangent theta. Tangent theta is 4 over b. So substitute tangent theta here by 4 over b. Which is 2 times tangent theta is 2 times 4 over b. Divided by 1 minus tangent square theta. So if tangent theta equals to 4 over b, it means that tangent square theta must equal to 4 over b squared. 4 over b squared equals to 4 squared is 16 over b squared. So in total, we found out that tangent square theta equals to 16 over b squared. That is minus 16 over b squared. So here, we will multiply this equation by 1 minus 16 over b squared. So in this side of the equation, we have 9 over b times 1 minus 16 over b squared. But on the other side of the equation, we have 2 times 4 is 8, so here in total we have 8 over b, and 1 minus 16 over b squared over 1 minus 16 over b squared is 1. So this expression will get cancelled, and we have only if 8 over b at this side of the equation. So in total, if we found out that 9 over b times 1 minus 16 over b squared equals to 8 over b. Here we have b on both sides of this equation, so b is cancelled. After it cancels b, this side of the equation we have 9 times 1 minus 16 over b squared equals to 8. So here we'll open the brackets of this side of the equation, and you get that 9 times 1 is 9. Here we have 9 times 116 is minus 144 over b squared. So in this side of the equation we have 9 minus 144 over b squared equals to 8. Here we subtract 8 from the equation. We get that 9 minus 8 is 1. So it is 1 minus 144 over b squared equals to 0. So here we add to this equation 144 over b squared over b squared plus 144 over b squared is 0. So in this side of the equation we have to remove f1, while on the other side of the equation we have 0 plus 144 over b squared equals to 144 over b squared. Here we will multiply this equation by b squared and get that b squared equals to 144. Here we take out all those equations and get that b equals to the square root of 144, this is 12. So b equals to 12 minutes and 7. So b equals to 12. Our task is to find out the area of this green shape. So what is the area of the green shape? From the drawing it is very easy to see that the green shape is actually the green triangle APC. So our task is to find out the area of the green triangle APC. Actually, we know that the area of any triangle equals to the base of the triangle times the height to the base over 2. So we choose the base of this green triangle APC as AP. The height to the base must create 90 degrees with the extended base. AP is the base, therefore the extended base is AB. So the height to the base must create 90 degrees with AB. CB definitely creates 90 degrees with AB because this is right again. So the height to the base is CB. Divided by 2. So to show now that the area of the green shape equals to AP, that is 5, times CB, that is 12, divided by 2. So to show now that the area of the green shape according to the second method equals to 5 times 12 is 60 over 2. 60 over 2 is 30. So the area of this green shape equals to 30 squares inside. So the next step, so in both methods, we found out that the area of this green shape equals to 30 squares inside. So in the next step, I'll start the lecture. We start with the repetition of the solution of the first question and then we repeat the solution of the second question on both methods. Our task in the first question was to find out the radius of this circle. So in the drawing, we have quadrilateral ABCD is described by this circle. AB equals to AD equals to 4. BC equals to 8. BC equals to 6 and CD equals to 8. Again, our task is to find out the radius of this circle. So first of all, we define this angle BCD as theta, and because of the fact that quadrilateral ABCD is a cyclic quadrilateral, that is to say, it can be described by a circle, the sum of those two opposite angles must be equal to 180 degrees according to all three. So repeat quickly on all three. The sum of those two opposite angles must be equal to 180 degrees according to rule 70. So repeat quickly on rule 70. According to rule 70, in any cyclic quadrilateral, the sum of the opposite angles is equal to 180 degrees. So quadrilateral ABCD is a cyclic quadrilateral because it is described by a circle. Therefore, according to this rule 70, the sum of those two opposite angles must be equal to 180 degrees. That is to say, alpha plus beta must be equal to 180 degrees. Likewise, the sum of those two opposite angles must be equal to 180 degrees according to this rule 70. That is to say, gamma plus beta equals to 180 degrees. So, can actually implement the rule 70 in our drawing. We put in our drawing quadrilateral ABCD is of course a cyclic quadrilateral. The sum of those two opposite angles must be equal to 180 degrees according to rule 70. But this angle equals to theta according to our definition. Therefore, this angle must be equal to 180 degrees minus theta. Why? Because 180 degrees minus theta plus theta is 180 degrees. It is the sum of those two opposite angles. In quadrilateral ABCD, this is a cyclic quadrilateral. So in total, we found out the missing angle. This missing angle equals to 180 degrees in its size. The next step, we join points B and D together by side line. By joining points B and D, we divided quadrilateral ABCD into two parts. The first part is the red triangle ADB. The second part is the white triangle BDC. So in the next step, we implement the law of cosines on both those triangles. So first of all, we implemented the law of cosines in this triangle BAD. So a quick picture of the law of cosines. This is triangle ABC, that could be a triangle. Triangle ABC. AB equals to A unit sinister, side AC equals to B unit sinister, side BC equals to C unit sinister. This is going to be AC. This equals to theta degrees in its size. So in this triangle ABC, that could be a triangle. According to the law of cosines, the following equation is called C squared equals to A squared plus B squared minus 2 times A times B times cosine theta. Again, C squared equals to A squared plus B squared minus 2 times A times B times cosine theta. So in the first step, we implemented the law of cosines in this triangle BAD. So in this triangle BAD, according to the law of cosines, BD squared equals to AB squared plus AD squared minus 2 times AB times AD times 180 degrees minus theta. And again, according to the law of cosines, in this triangle ABD, the following equation is true. BD squared equals to AB squared plus AD squared minus 2 times AB times AD times cosine theta. We have the trigonometric identity that says that cosine 180 degrees minus theta equals to minus cosine theta. So we can substitute cosine 180 degrees minus theta here by minus cosine theta. So in total, we found out that BD squared equals to AB squared. AB is 4, therefore AB squared is 4 squared, that is 16. plus DC square plus AD square. AD is 4, therefore AD square is 4 squared, this is 16. Minus 2 times AB, this is 4 times AD, this is also 4, times cosine 180 degrees minus theta. So in total, if you want all the BD square equals to AB square plus AD square minus 2 times AB times DC times cosine 180 degrees minus theta. But cosine 180 degrees minus theta equals to minus cosine theta. So in total, if you want all the BD square equals to 16 plus 16 minus 2 times 4 times 4 times minus cosine theta. So here we have BD square equals to 16 plus 16 is 32. Minus 2 times 4 times 4 times cosine theta is here we have minus times minus is plus, so this expression is a positive expression, and the value of this positive expression is 2 times 4 is 8, and 8 times 4 is 32. So this is plus 32 plus 32 times cosine theta. Again, according to equation 1, if you found out the total, this equals to 32 plus 32 times cosine theta. In the next step, we implemented the law of cosines on this right triangle BDC. According to the law of cosines on this right triangle BDC, the following equation is to BD square equals to BC square plus CD square minus 2 times BC times CD times cosine theta. And again, according to the law of cosines, in this triangle BDC, the following equation is to BD square equals to BC square plus DC square minus 2 times BC times DC times cosine theta. BD is the missing side, so we have to substitute, so it is BD square equals to BC square. BC is 6, therefore BC square is 6 squared, that is 36, plus this DC square. DC is 8, therefore DC square is 8 squared, that is 64, minus 2 times BC, that is 6, times DC, that is 8, times cosine theta. So total, if you want to know that BD square equals to 36 plus 64 minus 2 times 6 times 8 times cosine theta. So BD square equals to 36 plus 64 is 100, minus 2 times 6 times 8 times cosine theta, in total it is equal to minus 66. Again, you have minus 2 times BC is 6 times DC is 8 times cosine theta. So it is minus 2 times 6 is minus 12, and minus 12 times 8 is minus 96. So in total this expression equals to minus 96 cosine theta. So in total, if you found out that BD square equals to 36 plus 64 is 100, minus 96 cosine theta. This is according to equation 2, but according to equation 1, we only found out that BD square equals to 32 plus 32 times cosine theta. So we have two different equations for BD square. Therefore, we can do the equation 3 that says that BD square according to equation 1 must be equal to BD square according to equation 2. BD square according to equation 1 equals to 32 plus 32 times cosine theta. And it must be equal to BD square according to equation 2. BD square according to equation 2 equals to 100 minus 96 times cosine theta. So if subtract 32 from this equation 3, and find out that here 32 will get cancelled, so in this side of the equation 3 we have to only with 32 times cosine theta, while on the other side of the equation 3 we have 100 minus 42 is 68, so in total we have here 32 times cosine theta equals to 68 minus 96 times cosine theta. So here we have 96 cosine theta to this equation, so 96 cosine theta minus 96 cosine theta is 0, so in this of the equation we have to leave 56, In this side of the equation we have 68, while on the other side of the equation we have 32 times cosine theta plus 96, cosine theta equals to 128 cosine theta. So in total, if you roll into equation 3, 128 cosine theta equals to 68. So here we divided this equation 3 by 128, and finally found out that according to equation 3, cosine theta equals to 68 over 128. So here we can divide both the numerator and the numerator by 2. 68 over 2 is 34, and 68 over 2 is 128 over 2 is 64. So here we divided both the numerator of this expression by 2. 34 over 2 is 17, and 64 over 2 is 32. So in total, if you found out that cosine theta equals to 17 over 32. Cosine theta equals to 17 over 32. We have the trigonometric identity that says that sine square theta plus cosine square theta equals to 1. So here subtract cosine square theta from the equation, and when we found out that sine square theta equals to 1 minus cosine square theta. Here we took out of this equation, and when we found out that sine theta equals to the square root of 1 minus cosine square theta. When we found out that the cosine theta equals to 17 over 32. We square this equation, if we found out that cosine square theta equals to 17 over 32 squared. 17 over 32 squared equals to 0.2822. So in total, if you found out that cosine square theta equals to 0.2822. And we have the trigonometric identity that says that sine theta equals to the square root of 1 minus cosine square theta. So we can substitute in this trigonometric identity cosine square theta by 0.2822. We did it, and we found out that sine theta equals to the square root of 1 minus 0.2822. 1 minus 0.2822 is equal to 0.177. So sine theta equals to the square root of 0.177, and the square root of 0.177 is equal to 0.847. So in total, if you found out that sine theta equals to 0.847, what is the length of this chord BD? According to equation 1, if you found out that BD square equals to 32 plus 32 times cosine theta. And we already found out that cosine theta equals to 17 over 32. So if you found out that BD square equals to 32 plus 32 times cosine theta. And cosine theta is 17 over 33. So substitute cosine theta by 17 over 32. So here we have BD square equals to 32. We have 32 in the numerator, 32 in the numerator, so 32 we can get it, we left only 17. So in total, if you found out that BD square equals to 32 plus 17. Because if 32 we can get it, we left only 17. So in total, BD square equals to 32 plus 17, this is 49. Here we took out this equation. If I found out again, BD square equals to 17 plus 22, that is 49. So here to out of this equation, if I found out that BD equals to the square root of 49, that is 7. So BD equals to 7. Now we found out that sine theta equals to 0.847. The next step, implemented the law of sines. This right triangle BDC. Implemented the law of sines in the solution of this right triangle BDC. So a picture of the law of sines. the law of size is true in any triangle, so this is triangle ABC that could be any triangle. Triangle ABC is described by this again. AB equals to C units in itself, AC equals to B units in itself, BC equals to B, A units in itself, and angle BAC equals to capital A divided in size, angle ABC equals to capital B divided in size, and angle ACB equals to capital C divided in size. And this triangle ABC is described by this angle, and the other of this angle is R. So according to the law of size, the law of size in its full version, the following equation is to A over sinus A equals to B over sinus B equals to C over sinus C equals to 2R. Again, R is the other of this angle that blocks triangle BDC. So you can actually implement the law of size in our drawing. Here we have triangle ABC is described by this angle. Likewise, we have here also the right triangle BDC is definitely described by this angle. Why? Because of the fact that all the vertices B, D, and C lie on the circle itself. For that reason, you can implement here the law of size in its full version. And according to the law of size in its full version, in this right triangle BDC, the following equation is to BD over sinus theta equals to 2R. Again, BD over sinus theta equals to 2R, and R is the radius of the angle that we wrote before. Then again, according to the law of size, in this right triangle BDC, the following equation is to BD over sinus theta equals to 2R. BD is 7, and sinus theta is 0.847. 7 over 0.847 equals to 8.2644. So total, if you found out that 8.2644 equals to R, here we divide this equation by 2 and find out that R equals to 4.132 units in itself. Because again, the radius of this angle, R equals to 4.132 units in itself. So finish to repeat of the first question, and the next step, repeat of the solution of the second question on both methods. Our task in the second question is to find out the area of this relation. So in the drawing we have the big right triangle ABC. This is right triangle. This angle is CB. This equals to 2 theta degrees inside. AP equals to 5. APB equals to 4. Again, our task is to find out the area of this ratio. So first of all, we completed the missing angles in our drawing. We found out the missing angles in our drawing. This is the big right triangle ABC. In the big right triangle ABC, this is the right angle. This angle equals to 2 theta. Therefore, this first angle must be equal to 90 degrees minus 2 theta. Why? Because 90 degrees minus 2 theta plus 2 theta is 90 degrees. And 90 degrees plus 90 degrees is equal to 180 degrees. That is the sum of the angles in a triangle. Therefore, this first angle must be equal to 90 degrees minus 2 theta. Likewise, this right lower triangle BBC, this angle equals to theta, this angle equals to 90 degrees, and therefore this first angle must be equal to 90 degrees minus theta according to the sum that says that the sum of the angles in any triangle is equal to 180 degrees. So here we have from point P we go perpendicular on AC. Again, from point P we go perpendicular on AC. So this angle equals to 90 degrees, and this angle also equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point P and AC. This point is point Q. When doing this construction, we get the get PQC. The get PQC, this angle equals to 90 degrees, this angle equals to theta, therefore this missing angle must be equal to 90 degrees on theta, according to the sum of the set the sum of the angles in any triangle is equal to 180 degrees. Therefore, this missing angle must be equal to 90 degrees minus theta. What is the size of this missing angle APQ? The size of the missing angle APQ, according to all three, it must be equal, if you focus on the right side of the straight line AB at point P, here the sum of the angles must be equal to 180 degrees. So according to all three, this is the missing angle that we define as phi, plus 90 degrees minus theta, plus 90 degrees minus theta, in total must be equal to 180 degrees. So the missing angle Y plus the second angle that equals to 90 degrees minus theta plus the third angle that also equals to 90 degrees minus theta, and total must be equal to 180 degrees. So here, in this side of the equation, we have Y 90 degrees plus 90 degrees is 180 degrees, and minus theta is minus 2 theta. So in total, this side of the equation, we have Y plus 180 degrees minus 2 theta, while on the other side of the equation, we have 180 degrees. So here, subtracted 180 degrees from this equation, so here 180 degrees will get cancelled, and left only with Y minus 2 theta, while on the other side of the equation, left with nothing. So in total, we should know that Y minus 2 theta equals to 0. So here we need 2 theta to the equation, and we should know that Y equals to 2 theta. So the missing angle APQ, this is the missing angle APQ, this equals to 2 theta again in size. So in the next step, we prove that those two right angles can go into each other according to Euler's side angle rule. So why those two right angles can go into each other? First of all, those two angles are both equal to 90 degrees minus theta, and therefore they are equal to each other. In addition, side PC is the common side that belongs to both angles, so we can write down that PC equals to itself. It's the common side that belongs to both angles. And finally, those two angles are both equal to theta, and therefore they are equal to each other. So in total, if you want to know that those two angles can go into each other according to angle side angle rule. That is to say, if you found out that those two angles and the side that is included between those two angles in this great angle PQC are corresponding equal to those two angles, and the side that is included between those two angles in this right angle PBC, and therefore those two right angles can go into each other according to angle side angle rule. Again, we have those two angles, and the side that is included between those two angles in the great angle are corresponding equal to those two angles, and the side is included between those two angles in the right angle. Therefore, those two right angles can go to each other according to angle side angle rule. And again, if you remember that triangle, the great triangle APQ congruent, this is the side of congruent to the right angle PBC according to angle side angle rule. And so the fact that those two right angles can go into each other, we know that the corresponding sides must also equal to each other and the lengths. According to the rule, the sides that corresponding sides and congruent triangles are equal to each other. Okay, so therefore PB must be equal to PQ. According to the rule dimension, PB equals to PQ. PB equals PQ equals to PB. But it is given as a question that PB is 4. So we can write here that PB is 4. And for this equation, PB equals to PQ equals to 4. We derive that PQ must be also equal to 4. PQ equals to 4. This is the missing side PQ equals to 4. It is very easy to say that the big right angle ABC is similar to this small great angle APQ, according to angle similarity rule. Why the big right angle ABC is similar to this green small triangle APQ? First of all, this is angle A, this is a common angle that belongs to both triangles. So we can write down that angle A equals to itself is a common angle that belongs to both triangles. In addition, those two angles are both equal to 90 degrees and therefore they are equal to each other. And finally, those two angles are both equal to 2 theta and therefore they are equal to each other. So in total, I shall found out that all the triangles of this big right triangle ABC correspond equal to all the triangles of this green small triangle APQ. Therefore, the big triangle ABC is similar to the small green triangle APQ according to angle similarity rule. And again, in total, I found out that big right triangle ABC is similar. This is the sign of similar to the small green triangle APQ according to angle similarity rule. And from the fact that the big triangle ABC is similar to the green triangle APQ, we will learn that the following relationship exists between their sides. We will learn that side AP of the green small triangle APQ over side AC of the big right triangle ABC is equal to side PQ of the green small triangle APQ over side BC of the big right triangle ABC. And again, from the fact that the big triangle ABC is similar to the small triangle APQ, we learn that the following relationship exists between their sides. We learn that side AP of the small green triangle or side AC of the big right triangle ABC equals to side PQ of the small green triangle or side BC of the big right triangle ABC. So AP is 5. We define AC as A and BC as B. So AC is A according to our definition. Again, AP is 5, AC is A, and is equals to PQ. PQ is 4, and BC is B according to our definition. Again, PQ equals to 4, BC is B according to our definition. So in total, we should find out that 5 over A equals to 4 over B. Here we cross multiply this equation and we found out that 5b equals to 4a. What is the meaning of this equation? It means that if a equals to 5x, what is the value of b? The value of b, we just have to substitute a by 5x and this will find the value of b. So 5b equals to 4a. A is 5x, substitute a by 5x. So 5b equals to 4 times 5x. We have 5 on both sides of this equation, so 5 is cancelled. After cancelled 5, we left only with b equals to 4x. So in total, I should find out that if a equals to 5x, then b must be equal to 4x. Yeah. If a equals to 5x, then b must be equal to 4x. The next step, implement the Pythagoras theorem on this big right triangle ABC. According to the Pythagoras theorem, in any right triangle, the square of the opposite equals to the sum of the slopes of the perpendiculars. According to the Pythagoras theorem, in any right triangle, the square of the opposite equals to the sum of the slopes of the perpendiculars. This right triangle ABC, AC square, that is the square of the opposite, equals to AB square plus BC square. And again, this big right triangle ABC, according to the Pythagoras theorem, AC square, that is the square of the opposite, equals to AB square plus BC square. What is the value of AC? AC equals to 5x. AC equals to A and equals to 5x. So AC equals to 5x. Therefore, AC squared is 5x squared. 5x squared is 25x squared. And it's equal to AB squared. AB is 5 plus 4, that is 9. Therefore, AB squared is 9 squared, that is 1. Again, AB squared is 81 plus AC squared. AC is 4x. Therefore, AC squared is 4x squared. 4x squared is 16x squared. So in total, we found out that 25x squared equals to 81 plus 16x squared. Here we subtracted from this equation 16x squared, so here 16x squared is cancelled, and we have only 81, and on the other side of the equation we have 25x squared minus 16x squared is 9x squared. So in total, we found out that 9x squared equals to 81. Here we divided this equation by 9, we found out that 9x squared over 9 is x squared. 9x squared over 9 is x squared, and 81 over 9 is 9. So in total, we found out that x squared equals to 9. Here we took out all the equation, we found out that x equals to the square root of 9, that is 3. X equals to 3, let's insert. This is to say, AC equals to A equals to 5x. 5x is 5 times 3, that is 15. So AC equals to 15. Likewise, BC equals to B, and B equals to 4x. 4x is 4 times 3, that is 12. So in total, BC equals to 12, and AC equals to 15. Now test was to find out the area of this green shape. So what is the area of the green shape? The green shape is roughly the green triangle ABC. So our test could find out the area of the green triangle APC. So what is the area of the green triangle APC? We know that the area of the triangle equals to the base of the triangle times the height of the base over 2. We choose the base of this green triangle APC as AC. The height of the base is PQ because the green triangle is the base. But again, we choose the base of the green triangle APC as AC. The height must be PQ divided by 2. AC is 15. PQ is 4. Again, AC is 15, PQ is 4 divided by 2. 15 plus 15 times 4 is 60, and 60 over 2 is 30. So the total, if you found out that according to the first method, the area of this green shape is equal to 30 squares in size. We finish the first method. In the next step, after that, we have to find out the repeat of the solution of the second method. In the second method, we focus on this triangle PBC. This triangle PBC, triangle theta equals to PB over BC. Again, triangle theta equals to PB over BC. In the right triangle PBC, triangle theta equals to PB over BC. We define BC as B. So triangle theta equals to PB, that is 4, over BC, that is B. So in total, triangle theta equals to 4 over B. PB is 4, BC is B, so in total, triangle theta equals to 4 over B. This is the first equation. The next step, we focus on this big right triangle, triangle ABC. The big right triangle ABC, triangle 2 theta equals to AB over BC. Again, triangle 2 theta equals to AB over BC. Triangle 2 theta equals to AB over BC. AB in total equals to 5 plus 4, that is 9, over BC is B. So total, triangle 2 theta equals to 9 over B. And triangle 2 theta equals to AB, that is 9, over BC, that is B. So total triangle 2 theta equals to 9 over B. This is according to equation 2, and according to equation 1, we only found out that triangle theta equals to 4 over B. We have the trigonometric identity that says that tangent 2 theta equals to 2 tangent theta over 1 minus tangent square theta. We already found out that tangent 2 theta equals to 9 over B, and tangent theta equals to 4 over B. So we substitute tangent 2 theta by 9 over B equals to 2 times tangent theta is 4 over B over 1 minus tangent square theta. Tangent theta equals to 4 over B, therefore tangent square theta must be equal to 4 over B squared. 4 over B squared equals to 16 over B squared. So total tangent square theta equals to 16 over B squared. So here we found out that 9 over B equals to 2 times 4 over B over 1 minus 16 over B squared. So here we have, we multiply this equation by 1 minus 16 over B squared. So in this side of the equation we have 9 over B times 1 minus 16 over B squared, and on the other side of the equation we have 2 times 4 over B, that is 8 over B. Here 1 over 16 over B squared, we can cancel because we multiplied by 1 16 over B squared. Therefore we left in this side of the equation only with 8 over B. So 1 over 16 over B squared, we can cancel. So total, if you want to that 9 over B equals to 1 minus 16 over B squared, 9 over B times 1 minus 16 over B squared equals to 8 over B. We have B on both sides of this equation, so B we can cancel. After we cancel B, in this side of the equation we left only with 9 times 1 minus 16 over b squared, while on the other side of the equation we left only with 8. So total if you found out that 9 times 1 minus 16 over b squared equals to 8. Here we open the brackets of this equation and find out that 9 times 1 is 9 and 9 times 1 is 16 is 144 over b squared equals to 0. So equals to 8. Equals to 8, but the next step subtract 8 from this equation. 9 minus 8 is 1, so in this of the equation we have to leave 1 minus 144 over b squared, while here 8 over 8 is 0, so we have to leave 0. So today we found out that 1 minus 144 over b squared equals to 0. So here we added 144 over b squared to this equation. This of the equation we have to leave 1 because 144 b squared minus 144 over b squared is 0. On the other side of the equation we have 0 plus 144 over b squared equals to 144 over b squared. So in total we found out that 1 equals to 144 over b squared. Here we multiply this equation by b squared, and we found out that b squared equals to 144. Here we took out of this equation, and we found out that b equals to the square root of 144, that is 12. B equals to 12 units instead. B equals to 12 units instead. Our test is to find out the area of this green shape. What is the area of the green shape? The area of the green shape is the area of the green triangle ABC. Okay, our test is to find out the area of the green triangle ABC. The area of the triangle equals to the base of the triangle times the height of the base over 2. So the area of this green triangle ABC is equal to the base, we choose the base as AP. The height of the base must rate 90 degrees with the extended base AP. The extended base AP is AB. CB is the further rate 90 degrees with AB because this is right angle. So the height of the base is CB, that is B. Again, we choose the base as AP. Therefore, the height of the base must be equal to CB over 2. AP is 5, CB is B, that is 12. AP is 5, CB is B, that is 12 over 2. 5 times 12 is 60, 60 over 2 is 30. So, on both methods, if you found out that the area of this green shape, this is the area that we are looking for in this equation, is equal to 30 square units in size. Okay, thank you very much.